Okay, before you get into actually working with the equations for ellipses and hyperbolas, it's important for you to understand what exactly is an ellipse. So in our notes earlier, we looked at the definition of what a parabola was. So if you happen to look back at those notes or have those handy, what we did is we talked about a parabola being a set of points equidistant from the focus and the directrix. And we went through in that video with a piece of patty paper and measured those distances and showed that those were consistently the same. An ellipse is also a set of points, which means it's just going to be a nice continuous path. And what we've already seen is it kind of looks like a squashed circle. Okay, it's maybe squashed this way or it's squashed this way. And its definition is a set of points whose sum of the distances from a point on the parabola to what are called the foci, it's the plural of focus, remains consistent. In other words, what it looks like, for example, I've got just a kind of a quick and dirty model here. What we know is that if I measure this piece of string plus the length of this piece of string, that's not going to be any different than if I change, for example, how it's been cut apart. This length plus this length is still the same as, it keeps wanting to bounce off, this length plus this length. The string itself is not changing. All that's changing is how I am breaking it apart into different pieces. So what we can find with this quick little model is I can actually, sometimes this works better than others, I can move this pen around, and what we'll see is that the two individual distances are going to change. Their sum, of course, is going to remain consistent, and when I connect those dots, it's going to create what we know is an ellipse. Now remember, I am doing this with string and some nails on a board, but that's pretty good. We can see it kind of looks like a squashed ellipse. In fact, it looks like it's been stretched this way, and that's because my foci are oriented horizontally. If I changed the nails and I made them go up and down, or I moved them farther apart, the ellipse would change. Move them farther apart, it's going to become certainly flatter. If I change their orientation this way, it's going to become oriented or stretched vertically. So this is our major idea of what is an ellipse, and these 2 points, these foci, are going to be crucial for us. Now the center is going to be halfway between those, okay? So our center will be halfway between those, and if we think about how this connects to a circle, if I moved the foci closer and closer together, it's going to look more and more like a circle. In fact, if I moved the foci all the way to the center, it would actually then just graph a circle. So this is just kind of an important idea of what an ellipse is. It's more difficult to do a similar example for the hyperbola, because our hyperbola is going to say that the difference between these two distances is going to remain consistent throughout. So that's our big difference between an ellipse and a hyperbola, is that for the ellipse it's the sum, so it's easier to do this little path. For the hyperbola, it's going to be the difference. So just a quick little example of what exactly